Okay, in this video I'm going to show you how to work some probability applications involving the inverse normal distribution. So I have an example here with some statistics scores. So it says the mean grade on a statistics exam was 72 and the standard deviation was 9. All right, so remember that means whenever we draw the distribution, we're going to label the mean 72 and standard deviation 9. I like to put my standard deviation up top. It says these statistics were taken from last semester's student body at a local college, and 500 students were in a sample. All right, so that's a sample size there, as you can see. Letter A. The top 5% of the students will receive an A. All right, so now the top 5%, obviously, they're up here somewhere. The shaded region I'm going to draw is actually way bigger than it actually is. It's just that we're drawing it so that we can see it. All right, so here's the top 5% up here. And there's a score there. So this is 5%. That shaded region. And there's a score right there. We don't know what it is. One thing I know for sure is it's bigger than 72. What's the minimum grade that the student must get in order to receive an A? All right, so in other words, this score right here, this X value, that is the minimum score that you would get if you wanted an A. And if you got anything higher than that, in this region, in that 5% region, you would still get an A. All right, so remember, this is the scenario for the inverse normal, where we have the area and we're looking for the raw score. Remember, if you have the raw score and you're looking for the area, which represents a probability, that's the normal CDF operation, when that's a forward operation. Most people think of this as the reverse operation. All right, so in your calculator, remember, second vars. I showed you in an earlier video how to use the normal CDF operation. This is the inverse normal scenario, number 3. So I'm going to select option 3, inv norm. Now, I have the new calculator, so it picks your brain as to what's the area, what's the mean, and what's the standard deviation. Now, the thing with the calculator, depending on how new your calculator is, I would say the majority of calculators, when it says area there, it wants the area on the left. So the area to the left of this boundary right here, since the area on the right is 5%, the area over here is 95%, so I'll write that as 0.95. Now, the CDF stands for cumulative distribution function, and this, C means cumulative, which means from the beginning. So these functions in the calculator are cumulative functions and therefore require areas on the left. All right, so the calculator statement, inv norm, and the syntax, if you have the old calculator, is area on the left, which is 0.95, which is weird because, the question talks about the top 5%. But notice I'm not using 5% in here. Followed by the mean, which is 72. Followed by the standard deviation, which is 9. Now, you've seen in the textbook how to do this by hand, converting the, looking up the z-score, and then doing a backwards lookup in the z-score table. And that's exactly what's going to go on here. It's just that the calculator is going to do that for us. So the area on the left is 0.95, mean is 72, and the standard deviation is 9. Now, right above this paste feature in the calculator, if you have the super new calculator, which I don't even have that one yet, but I've seen some of my students have it, you might have a scenario where it says, what kind of area are you giving that 95%? Is it an area on the left? Is it an area on the right? Or is it an area in the middle? And you have an option there to select what kind of an area you're giving it, which is kind of nice. That would allow you to use the 5% and say, hey, I'm giving you an area on the right, and the area is 5%. The calculator I have doesn't have that feature, unfortunately. So, and I would estimate that most of the calculators out there, but probably 90% of them don't have this feature. All right, so when you paste it, it looks like the old-fashioned TI-83 output, and then it does that backwards lookup for me. All right, so let's round that. Call that about 86.8. So this is about 86.8, which makes sense. We knew it was bigger than 72. All right, letter B. What score separates the top 2% from the lower 98%? All right, well, you know what? That's the same question. I mean, this area up here, if that area is 2%, this area down here is 98%. I mean, it's virtually identical.
My web search turned something up for down here as 98% mean. Have a look.
No, thank you, Siri. As you can see, Siri's giving me her opinion. So, virtually the same question. So, inv norm area on the left, which is 0.98. The mean is 72, and the standard deviation is 9. Let me put my mean on here. All right, so let's go ahead to the calculator. I mean, this letters A and B are virtually the same question. So remember, if you have the statement up there, if you hit second enter, all I have to do right now is change this to 0.98. Again, area on the left, comma mean, comma standard deviation. Now, I know this answer. I don't know it off the top of my head, but the one thing I know for sure is it's bigger than 86, right? We know that. All right, 90.48. Yeah, let's call that about 90.5. Remember, the rounding here, we don't have to go crazy with the rounding here. We're just doing an example that we're talking about. Now, my math lab is very particular about the rounding, and they always tell you what to round to. So, all right, let's give a look at letter C. What score cuts off the lower 100 students? You know, and at first glance, this doesn't look like a normal CDF, an inverse normal scenario. So this is the mean of 72. Standard deviation is 9. Now, the lower 100 students, you know, they're over here. Again, I'm going to make the area bigger than I actually have to so we can see it. So we don't know what that score is. We're trying to find. So here's the lower 100. And you know, that lower 100, that's a number of students. That's not a percentage. So that's not an area on the left. So, you know, the question's asking me to find this x. And so you're saying, all right, if they're asking me to find x, I know it's an inverse norm scenario. But, you know, if I'm looking to do an inverse norm scenario, I need a percentage. And the lower 100 students is not a percentage. Well, you know what? It kind of is, because they let us know before that there's 500 students in this sample. So when they say the lower 100, they mean the lower 100 out of the 500 students. And 100 out of 500 is 1/5, which is 0.2, which is 20% of students. All right, so that, in a roundabout way, is a percentage. All right, so my calculator statement, inv norm. Area on the left. Now, if you want to type that in your calculator and get it as a decimal first, go right ahead, but I don't see a need to. Let the calculator calculate that for you. So there's this is technically a decimal, which is a percentage, which is an area to us, right? 72 is the mean, and the standard deviation again is 9. All right, so we'll go back to our calculator. Second enter, and I'm going to change that 0.98 to 100 out of 500. Now, it won't fit in there, obviously, so I'll type the 100. Then I got to hit insert, divided by 500. All right, so there it is. And again, if you wanted to convert the 100 divided by 500 into a decimal for yourself, go right ahead, but I don't see a need for that. All right, so again, we knew the answer, by the way, common sense-wise. We knew it was less than 72. And as you can see, it's about 64.4, you know, ballparks. It's about 64.4. All right, let's give a look at the last one. What score is at the 75th percentile? All right, so again, here's the mean of 72. Standard deviation is 9. The 75th percentile, that is the guy that beats or ties 75% of the people that we're talking about here, right? All right, well, right here in the middle, this number 72, if you got to 72, you're at the 50th percentile because you beat half the people, right? And the other half the people beat you. So the 75th percentile is going to be somewhere over here, right? Again, we don't know what the score is yet. But the one thing we know for sure is that this area in here is 0.75. So if I got this score right here, whatever it is, then I beat the 75% of the people, or tied, naturally. All right, so this is just a fancy way of, you know, saying find the score that separates the lower 75% from the upper 25%. All right, so inv norm. That 75% is an area on the left, comma the mean, comma the standard deviation. All right, so let's go to our calculator. Change this to 75%. All right, so area on the left, 75%. common to the mean, common to standard deviation. 78.1 ballpark, which makes sense. Center 72, that's the 50th percentile. 78.1 being the 75th percentile. All right, so as you can see, these applications involving the inverse normal distribution, they're kind of all the same. You can sit here and do 20 of them in a row, and they're all going to feel exactly the same, really. All right, so if you have any questions, feel free to email me. Thanks for watching.